Thanks for coming to find out more about our project. My name is Tess, and along with my teammates Tamara and Jaya, we'll take you through our poster to give you an overview of our project. I'll begin with a summary of what we have achieved through this project. The fundamental output of our research is an inventory of key construction materials that make up detached and semi-detached houses in the Melbourne metropolitan area. This inventory gives information about the quantity, location, and age of materials and can be used by other researchers, the construction industry, and policymakers to help break down barriers to material circularity. Key drivers of the project include rapid urbanisation and growth occurring in the Melbourne metropolitan area, and the current unsustainable resource depletion by the construction industry, as barriers prevent the recycle and reuse of materials. Our research objectives were therefore to create an inventory of high volume and hazardous materials per local government area, and then to apply this to the estimated material demand for 2051, showing the energy, greenhouse gas, and cost savings by recycling high-volume materials in new housing. To achieve this, we developed the following methodology. We began by defining a set of archetypes which typify housing in Melbourne. Using existing data, we then quantified how many of these archetypes can be found in each local government area. Combining this with the total amount of materials per house, we were able to estimate the total amount of key construction materials at an LGA level. We then mapped the data using GIS, which Tamara and Jaya will explain shortly.
Here we defined 7 different typologies for both detached and semi-detached houses, based predominantly on the year in which they were built. These were then further broken down into archetypes, which were also based on roof material, outer wall material, and whether they are 1- or 2-story houses. In total, we have 38 archetypes on which to build our material inventory. This inventory was then used to be able to locate materials across Melbourne. Here it can be seen that there is a larger amount of timber within the inner city suburbs, most likely attributed to older houses such as those with weatherboard and timber stumps. It can also be seen that areas with low number of housing also will have lower intensities. And finally, it can be seen that concrete has a much larger amount compared to other materials, with brick coming in second. Our inventory can also be used for hazardous materials. Here we see the likelihood of asbestos contamination. Inner city houses have the highest likelihood of contamination, with 74% of residential buildings within the city of Yarra having a highly likely risk of contamination.
We can show material use trends throughout time. Using brick as an example, when comparing pre and post 1990, majority of the brick stock is located in the central Melbourne metropolitan area pre-1990 and on the outskirts post-1990. This follows the housing trend of older typologies located in the central region and recent housing on the fringes. The same is shown when you zoom into the time era itself. For example, pre-1990, brick is common in terrace and bungalow in the central region with the orange and blue in the pie chart, and in comparatively recent housing on the outskirts. Our inventory can estimate saving potential through reuse and recycling. For example, keeping up with the theme of bricks, 24.6 megatons of brick is required to meet housing demands in 2051. Assuming a 60-year house lifespan and 88% recyclability rate, our inventory shows we can reuse and recycle 18.4 megatons of brick from current material stock. This equates to 75% energy savings, 37% cost savings, and 75% greenhouse gas savings when compared to sourcing raw materials alone. In conclusion, our project combines key material and housing with their distribution and age into an inventory. And it's this inventory that lays the groundwork for further applications. This includes expanding the scope of buildings, expanding quantified materials, developing a material quality algorithm, and introducing transport-related cost and emissions. Thank you for taking interest in our project, and we hope to see you at the Endeavour exhibition.